Good afternoon to all. Am I audible? Message in the chat box. Yes, type yes in the chat box if I am audible. At the end of this session, I will forward a link. Fill that. It's a Google form to provide attendance to you. Okay, you can fill the Google form at the end of this session. Am I audible? Okay, okay. So today's session is on energy resources. So the energy sources, they are used to provide, they can provide heat, power, or electricity. So usually the materials that store energy are known as fuels. So most of the energy comes from fossil fuels, as you people already know. So these fossil fuels, they are non-renewable energy sources which harm the environment when they are in use. So all the energy sources except solar energy, um, all the other energy sources. I mean, solar energy is also an energy source. So, except solar energy, all the other energy sources are the materials that are obtained from the earth. Okay, so energy sources can be classified into two types. So, they can be classified into two types. If you want, you can note it down. I'm taking the pointer. So, energy sources are classified into two types: conventional energy sources, or you can even call it as non-renewable energy sources. Other type of energy source is non-conventional energy sources, or you can call it as renewable energy source. So, energy sources can be broadly classified into two types of energy sources: conventional energy source or non-conventional energy source. Okay, otherwise, conventional energy source can be called as non-renewable energy source, whereas non-conventional energy source, it is known as renewable energy source. If you want, you can note it down. So I have some images of these non-conventional and conventional energy sources. The images are, slide is not changing. Okay. Okay, so these are some examples of non-conventional energy sources. You can see here. This is our solar energy source. This is wind energy source. Okay, solar energy, wind energy, tidal energy, geothermal energy, and biomass. Okay, so these are all the examples of this non-conventional energy sources. Okay, so these are some examples: solar, wind, tidal, geothermal, and biomass are the non-conventional. Whereas conventional energy sources examples are coal or oil that is obtained here. I have written petrol, but you can we can oil that is available in the underground of this earth. So that is one of the conventional energy source. Another one is natural gas. So if we discuss in detail about these conventional energy sources, we can even call them, as I've already told you, conventional energy sources, you can even call them as non-renewable energy sources. Okay, so these conventional energy sources, they are available in limited quantities. Okay, so they are not abundant, they are available in limited quantity. That means that if we use them in excess, what will happen is they will extinguish. Okay, so they are available, these conventional energy sources are available in limited quantities. If we use them in excess, what will happen? They will extinguish. So, for example, as I already told you, which are visible on the screen, that is coal, oil, or the natural gas, they are limited. Okay, so if they are used, means if we are using in lump sum, if we are using these energy sources a lot, then what will happen is they will extinguish and we cannot get them back. Okay, if the coal, oil, or the natural gas is used in abundance by the humans, if we are humans are the one who need these energy sources. So if we use them, then they cannot be replaced. Okay, if they are extinguished. So these conventional energy sources, they can further be categorized into two types, that is commercial energy source, non-commercial energy sources. So conventional energy sources, you can further categorize them into two types. One of the type of conventional energy sources is commercial energy source. Another type is non-commercial energy source. So you can note it down. If you have any issue, you can mention in the chat box. If my voice is not audible or if there is any issue, you can mention in the chat box. So at the end of the session, I will forward a link so that you can, I'll forward the link so that you can fill that Google form that is being forwarded in the, I will just upload it in the chat box. Okay. So conventional energy sources, you can categorize them into two types, that is commercial energy source and non-commercial energy sources. Those, so the commercial energy sources are the coal, electricity, and petroleum. Okay, so these sources, if you want these sources, the customer have to purchase it from the person whoever is selling it. So we can't get them freely. Of course, they are available underground, but the customer always has to purchase it. So the government will look after these sources. So it is under the what is it is the responsibility of the government to look after these sources, and we have to purchase it from the uh, whoever is in charge, whoever is selling this. So this is coal, which is one of the commercial energy source. Okay. So and one more commercial energy source is oil and natural gas, as I have already told you. You can see here. This is the uppermost layer of the earth. Okay, this is the uppermost layer. Where is pen has gone? Okay, I will take laser. So this is the uppermost layer. So these are the different layers of earth, starting from the top upper layer. So you can see as we move into the towards the center of the earth, we can say, as we move downwards, you can see here gas. Okay, and below that you can see oil, and below that water is there. You can see. So we usually use water pumps to get the underground water, isn't it? So you can see a water pump here on the right side, and you can see some pipe has been fixed here to get the oil from the ground. So the gas and oil they are also commercial energy sources. They will extinguish if we use very means in lump sum. If we use, they will extinguish quickly. But and they are not easily available to the customer. We have to purchase it. One more type of commercial energy source is electricity. That is electricity. So electrical energy is generated at the generating station. Okay, so here this is our generating station. Okay, so you'll see electricity is generated at a power plant. So this is the generating station. From here you can see to this generating station. There is a step-up step-up transformer is connected. So electricity travels through the transmission line he has mentioned. So transmission line, this is a transmission line, this transmission tower. Okay, so here it is stepped down and it is given to the load. So here you can see a small house has been shown, for example. So that is our that is a domestic load, of course. Okay, so load can be commercial or domestic. I'm erasing all links. So even electricity, we people know that we have to purchase electricity. We are paying for electricity that we are using. Okay, so let us discuss a few more things about these commercial energy sources. So coal is one of the commercial energy source. Coal is significant energy source. Okay, and it is abundant in various regions of this world. Okay, it is available in various regions of this world, including India. Okay, and India ranks among the top coal producing countries. Among many countries in which coal is available, India is one of the top coal producing country. Okay, and the regions where the coal is available in India are Bihar, Orissa, Madhya Pradesh, Jharkhand, and Bengal. Okay, in these regions, coal is available. So to discuss few more points about oil and natural gas, you can refer this oil. Okay, oil you can call oil as, usually oil is called as black gold. Okay, it is also called as black gold. So it is one of the crucial energy source in our India as well as globally also. Okay, it is one of the crucial energy source. Okay, so it is oil is used in various modes of transports, as we people already know, such as in cars, trains, and aeroplanes, etc. And this oil production, so extracting oil from the ground, okay, is it has been significantly growing day by day from many years. Okay, there are many substantial reserves found in various regions in India for oil. Uh, those areas in oil where area oil is found in India are Assam, Gujarat, and Mumbai. Okay, and one more energy source is commercial energy source is electricity, and it is the most common form of energy source used for both the domestic as well as commercial purpose. Here in this image, I have shown you only domestic. Only I have shown you only domestic load. This is the load. House is the load. So commercial places are like offices, industries, and all are commercial places. Okay. So this electrical energy, it is used to energize various appliances in our houses. For example, I'm talking about the houses. In our houses, we know, even to turn on the light, we need electrical energy. To turn on the fan, we need electrical energy. To turn on the washing machine, television, refrigerators, we need electrical energy. Okay. So, electricity is the most well-known energy source for us. So there are different sources of electrical energy. Okay. So the electrical energy is generated uh, by different methods, I can say. Okay. So primary sources of electrical generation here I have mentioned here. So electrical energy can be generated uh, in different ways. One of the source for generating the electrical energy is nuclear energy. Okay. Other one is thermal energy. Other one is hydro energy. And few more are there. Tidal. Okay, we can even use tidal energy to generate the electricity. We can use wind energy to produce electricity. We can use biomass also to produce the electrical energy. So here, just for example, I have mentioned only three sources of electrical energy generation. If you want, you can note it down. You can write down few more. Okay, and I have even I have even gathered some images from the internet. So nuclear power generating station is this. Okay, and thermal power station where electrical energy is generated, and one more hydroelectric power station where electrical energy is generated. I think only three images. Yeah, only three images I have kept here. Okay. So if we talk about nuclear power station, okay, so the nuclear power is generated by harnessing the energy released during nuclear reaction. Okay, so if we are using nuclear energy, okay, if we are using nuclear energy to generate electricity, okay, so in nuclear power stations, nuclear power is generated by harnessing the energy released during nuclear reaction. And uranium is the product that is used. Okay, means uranium is the fuel that is used in nuclear power plant. Okay, which is less expensive than coal. Okay, so the uranium is the material which is used to generate the electric power in the nuclear power plants. Okay, so if we talk about the thermal power plant, so here what is done is fossil fuels are used, such as coal or oil are used to generate the electrical energy. Okay, and majority of the electrical energy in India, approximately 40% of the electrical energy in India is generated by the thermal power plants. Next, if we talk about the hydroelectric power plant to generate the electrical energy, so here water energy stored in the water. Okay, so when energy stored in the water is used for converting tidal energy into electrical energy. Okay, so this water is used as energy source here to generate the electricity. So that is achieved by constructing dam on rivers. Okay, usually you can see a dam here. So in this image, usually dams are constructed to utilize the energy, water energy to convert it into electrical energy. Okay, so this is all about the conventional energy sources. Now let us discuss non-conventional energy sources. Okay, so you can even call non-conventional energy sources as what? Renewable energy sources. Yeah. So you can call. I wanted the pen. I think it was already there. It has been. We can even call the conventional energy sources as renewable energy sources. Non-conventional, sorry, not conventional. Non-conventional energy sources, you can even call them as renewable energy sources. So the renewable energy sources, okay. So these they will never extinguish. Okay. So they are easily available and they will never extinguish. So examples of renewable energy sources or non-conventional energy sources are solar energy, wind energy, bioenergy and tidal energy. Okay, so these are the examples of non-conventional energy sources. So I have some images. So you can see solar energy, example of solar energy. So here solar energy, the energy, heat energy of the sun is utilized here to convert it into electrical energy. Okay, and one more is wind energy. Here, wind energy when wind blows. Okay, here when wind blows, that wind energy is used to get electricity. Okay, similarly, bioenergy. Okay, next, tidal energy. Okay, so let us discuss briefly about each energy system. So, solar energy is derived from the sun. Okay, so here what is done is photovoltaic cells are used. Okay, photovoltaic cells are used. So these photovoltaic cells convert sunlight into electricity, which can be used for various purposes, including whatever you want. You can use it for cooking purpose or for water purification or for any um, whatever electrical energy need that you have, that can be fulfilled by this solar energy. So if we are using wind energy, so wind energy is generated by simply harnessing the kinetic energy of the wind. Okay, and it is commonly used to power water pumps, generally for irrigation. This wind energy is commonly used for irrigation purpose, for pumping water in the fields. So India is one of the leading countries for wind power generation. Okay, so if we discuss about tidal energy, so tidal energy is generated by harnessing the energy of sea tides. So you can see here high tide is there and low tide is there. So simply harnessing the energy of these tides, okay, uh, electrical energy is produced. So this is a most cost-effective method. In bioenergy, the bio waste means biodegradable materials, okay, are used. They are put into these big, what is it, chambers. You can call them as chambers or well-like structures. So they are okay. They are allowed to stay in those wells for many days, okay, for a longer period, and they will, when the biodegradable elements decay, they will release some gases. Those gases are used for generating the electrical energy. Okay, so to what to say, you can what to say, all these energies, the sources of energies that we have discussed, you can um, draw in a, what to say, in a flow chart, okay, or you can mention in one slide like this, okay. So here, sources of energy, you can categorize them into conventional source and non-conventional sources. Conventional sources are further categorized into commercial, non-commercial. Okay, examples of commercial sources are coal, petroleum, and electricity. Examples of non-commercial are firewood, straw, and dried dung. Okay, and non-conventional energy sources. You can, the examples are bioenergy, solar energy, wind energy, tidal energy, um, energy from urban waste. Okay, if you want, you can draw this. I'll give you a minute. I will just erase the mark. You can draw this. If you complete, just inform. Mention C. Just type C in the chat box so that I will proceed. Did you complete? Okay, no response is there, so I will proceed. Have been waiting. I don't know whether you people are writing or not. So let us discuss some of the electrical energy generating power plants. Okay, electrical energy generating power plants. Let us discuss some of them. So one of the electrical energy generating power plant is hydroelectric power plant. So one of the cleanest method of producing electrical energy is by using the hydroelectric power plant. Okay. So generation of electricity by hydroelectric power plant is one of the cleanest method. So in the year of 2012, hydroelectric power plant contributed around 16% of the total electrical energy generation in India. I'm sorry, not in India, in the whole world. Sorry, in the whole world, the approximately 16% of the electrical energy was generated by the hydroelectric power plant in the year of 2012. Okay, so it is one of the most widely used renewable energy source. So it is a flexible source of electricity, and the cost of electrical generation is relatively very low. Okay, here we don't require any fuel. So wherever water resources are available on the earth, we will these electrical hydroelectric power plants are built. So these hydroelectric power plants are usually built in the locations wherever water sources are available. Okay, so I have one more image here. So you can see wherever red mark is there. If you see, this is India. Wherever red mark is there, hydroelectric power plants are available in India. Okay, these many hydroelectric power plants are there. Red dots. So you can see here at the bottom, this I got it from the internet. It's hydropower plant, red dot hydropower plant. So all these red dots wherever you can see these many red dots here. So these are all the red dots resemble that hydroelectric power plants are available at these locations. Okay, even in here, hydroelectric power plants are available. Okay. So the basic components of hydroelectric power plants are dam and reservoir. So dam and reservoir, you can see here in this image, you can see upper reservoir it is mentioned. Here it is mentioned lower reservoir. So I think I have one more. Yeah, this is it. So this is the reservoir where water is stored. It is kept at high potential. This is the dam. Okay, this is the dam. Okay. So one of the component of hydroelectric power plant is dam and reservoir. So this dam, okay, this dam is constructed on a large river in a hilly areas usually. Okay, it is so you can see this is the earth. You can see here it is flat, and this dam is built at higher location. This dam is built at higher location. Okay, so usually these dams, okay, these dams they are constructed on a large river in hilly areas to ensure sufficient water storage at height. So we want to store water at height. Okay. So in order to store the water at height, usually dams are constructed on a large rivers which are located at hilly areas. So the dam forms a large reservoir behind it. Okay. So the height of the water level, which is known as water head. Okay, so height of the water level. This is the height of the water level. This is water, isn't it? In the reservoir, this is the water. So height of the water level, which is known as water head in the reservoir, will determine how much of the potential energy is stored in it. So when water is stored at a height, so potential energy is stored in it. Okay, so when water is stored at height, what will happen is potential energy is stored in it. Okay, so now let's go to the one more component, that is control gate. Okay, so you can see here, I will just erase the ink. So I will erase. Yeah, this is the control gate. This is control gate. So water from the reservoir is allowed to flow through the penstock to the turbine. So you can see this is penstock and this is turbine. Okay. So this is the control gate. So penstock is nothing but a huge pipe-like structure. That's it. This is pipe. So I have one more image somewhere. I have image. I will show you the penstock. Penstock. I have real image. See here, in this image, you can see this is the penstock. Okay, so penstock is nothing but a pipe. Yeah. So here, let us. So here, what happens is, in the water from the reservoir is allowed to flow through the penstock to the turbine. Here it is the turbine. Okay. So the amount of water which is to be released into the penstock can be controlled by this control gate. So if you carefully observe here, this is the total space that is available. If you observe, the gate is not fully open, isn't it? Only or so gate is not fully open in this image. Oh, this is just an image. Only this portion is open to allow water to flow into the from the reservoir into the penstock. Okay. So it is in the hands of the control gate to control how much water to flow into the towards the turbine through the penstock. So Uh, one second. Okay, okay, okay. When the control gate is fully open, if suppose here it is not open in this image, if the control gate is fully open, maximum amount of water is released through the penstock towards the turbine. Okay, if the control gate is fully open. Okay, so I'll give you just, if possible, you can draw this. I'll give you a minute. You can, if you want, you can draw it. Huh? While I'm explaining, you can draw it. So this image. Slide has changed. Okay then. So I have discussed about the control gate. So penstock is what? It is a huge steel pipe. As I already shown you on image earlier, this penstock is a huge steel pipe which carries water from the reservoir to the turbine. Okay. So the potential energy of the water is converted into kinetic energy as it flows down through the penstock due to gravity, isn't it? So definitely water is stored at height here in the reservoir. The cursor, yeah, in the reservoir, water is stored at a height. So when this control gate is open, what will happen? The potential energy, PE, okay, the potential energy that is stored in this water will convert into what? Kinetic energy while going down from the reservoir towards the turbine. Okay, so simply gravity will act. Here there is no need for us to pull the water from the reservoir towards the turbine. As soon as gate opens, because the turbine is at lower position, reservoir is at height, definitely due to gravity, water will start to flow from reservoir towards the turbine. Okay, now let us discuss about this turbine. Okay, so turbines. So I have many images actually. So one more, see here, this is penstock. So this is turbine. So I have few more images. There are different types of turbines. So this is Francis turbine, this one. Fixed pitched propeller, this is known as fixed pitch propeller. Turbo type turbine, this is Pelton turbine, this is Pelton turbine. Kaplan turbine and cross flow turbine. So there are different types of turbines that are available in the market. Okay, so one of the simplest form of turbine is this. Okay, so to know more about the turbines, the mechanical engineering students, they have a subject known as fluid mechanics. In that subject, they will learn more about the types of turbines, how do they function, how do they operate, and even they have a laboratory for doing the experiments on these turbines. Okay, so you can see here, this is one of the turbine. Let me check if I have few more images. Yeah, I have few more images. Yeah, this is no this one. So you can see these are cups. Okay, these are cups, double cups side by side. You can see these are cup-like structures. So if with force when water falls on these cups, what will happen? Okay, what will happen? These cups are, because of the force, they will be pushed back. Okay, so when this cup pushed back, when water will fall on this cup, that is also pushed back. And what will happen? This turbine will start to rotate. Okay, this turbine will start to rotate. So let me see. You can see when from the penstock, when water falls on this turbine, see these turbines are pushed back, and next turbine will come to this position. And when water falls on that turbine again, not turbine, I'm sorry, cups. When water falls on these cups, one after another, as they are moving back, water will be falling, okay, on the next cup as it comes to the position of the previous cup. Okay. So this turbine, so where is the cursor? Yeah. So uh, this is the shaft of this turbine. The shaft of the turbine is coupled to the generator. Okay. So see here, this is known as belt. This known as belt. The shaft of the turbine is coupled to the generator shaft. This is the shaft of the generator. So when turbine starts to rotate, what will happen? The armature or the rotor of the generator will start to rotate. Okay, so when the turbine starts to rotate because of the when water falls on the cups, these cups of this turbine, what will happen? Turbine will start to rotate. When turbine rotates, as the shaft of the turbine is coupled, mechanically coupled with the shaft of the generator, what will happen? The stator of the generator will start to rotate. And we know, okay, I think I have one more image. This one. So this is it. This is the shaft. Here it is mentioned. See here it is mentioned shaft. So this red light structure is this is also shaft. Okay. So in between some gearbox is there. This is our generator. Okay. So this is shaft. Here also it is mentioned shaft. Okay. So when water falls on these cups, they start to move. The turbine will start to move. As turbine moves, shaft will move. and hence generator shaft will also start to move as generator is mechanically coupled with this turbine. So we know when conductor cuts the magnetic field, EMF is induced in the generator. You know the operation of the generator. So okay, this is how electrical energy is generated. Okay, so here the kinetic energy of the water will drive the turbine, and consequently what will happen? Generator gets driven by this, means stator of the generator will start to rotate, and hence what will happen? As stator of the generator starts to rotate, sorry, it's not stator. Stator is the static part. Rotor of the generator will start to rotate. As rotor of the generator starts to rotate, the rotor windings will cut the magnetic field of the stator, and hence what will happen? EMF is induced in stator windings. Okay, so hence electrical energy is generated by the generator, and that can be utilized by the commercial load or the domestic loads. Okay, so these turbines, they can be classified into two types. Impulse turbine. So here the image that I'm showing you here is impulse turbine. So you can classify them into two types. One of the type is impulse turbine. So usually the impulse turbines are used for large heads. Okay. And one more type of turbine is reaction turbine. This is reaction turbine. Okay, so real image, I have the real image of the reaction turbine. This is how the reaction turbine looks like. So usually for low head or medium heads, um, reaction turbines are used. Okay, so next is, so see here. So head means, as just now I have told you, low head, medium head, or high head. Okay, so I have told you that impulse turbines are used for large head, and reaction turbines are used for low and medium head. Head means, if you see here, pen is there, okay. So this is the level of the water in the reservoir. This is our reservoir. This is the level of the water. Okay. Now, when water flows from this reservoir, where is my cursor? From the reservoir through the penstock, this is our turbine. Okay. And after passing through the reservoir, it will go and it will be stored at lower level. Okay, so whatever is the highest, means whatever is the level of water at the, we can call this as lower reservoir. Somewhere there was an image, isn't it? Earlier, I think I showed you. Lower reservoir and upper reservoir, somewhere it is there. Yeah, river, reservoir, it was somewhere. Low reservoir and upper reservoir, I have already shown you earlier. Now I am unable to find it. Yeah, it is there, it is there. I have to go up. Yeah, no, above it. I think I have missed the image. Yeah, it is there. So see here. So this is upper reservoir. This is lower reservoir. Means after passing through the turbine, water after passing, this is our turbine. After passing through the turbine, the water will go and settle in the lower reservoir. Okay. So this is the tip of the lower reservoir. This is the tip of the upper reservoir. So the difference in these tips, from this tip to this tip, that is known as head. Okay, so if I am using impulse turbine, okay, there are two types of turbines, isn't it? Impulse turbine and reaction turbine. This head will be large for impulse turbine. Means if this head is large, okay, this length, this distance between the heads, head of this lower reservoir and head of this upper reservoir, if the this difference is large, then the turbine that is used here is impulse turbine. If this head is low, then the turbine that is used here is, okay, used here is low or medium, I'm sorry, reaction turbine. Okay, so for low and medium heads, okay, I hope you have understood. Okay, if the head means what? Head means this is the tip of the upper reservoir, this is the tip of the lower reservoir. So if this distance is large, which distance? Tip of upper reservoir and tip of lower reservoir distance is large, so then we can call it as large head. Okay. See, for in such cases, the turbine that is used here is impulse turbine. If this length is low, then the turbine that is used is reaction turbine. Okay, so that is head image. I will show you once again. Okay, where was it? Somewhere it was there. This is it. This is the head. Okay, so depending on head, either reaction turbine is used or impulse turbine is used. Okay, and we already know about the next portion. Next part is generator. So we already know about the generator. So where is that image? So this is our generator. Okay. So we already know about the generator. So if we discuss about the generator, we know that it generates the electrical energy. So it is generator is mounted in the powerhouse and it is mechanically coupled to what? Turbine shaft, as I also already shown you. Generator is coupled to the turbine shaft. Somewhere some image was there. Where was it? I'm unable to find the images. Huh? So you can see in this image, this is generator, this is turbine. It is mechanically coupled. This rod is the shaft. That rod is the shaft. So it is mechanically coupled to the turbine. So when the turbine blades are rotated, blades means cups. Okay, cups means where is it? These are the blades. You can call them as blades. These cups. Okay, these are the blades. Okay, these cups. These cups you can call them as turbine blades. So when the turbine blades are rotated, okay, what will happen? The shaft of the turbine will rotate. When the shaft of the turbine rotates, automatically the armature of the generator will rotate. Means rotor of the generator will rotate. When rotor of the generator rotates, the rotor windings are rotating. When rotor windings are rotating, they will cut the magnetic field, stator magnetic field, and EMF is induced in the generator. Okay, so this generated electricity is then stepped up with the help of a transformer and it is transmitted. Okay, like one more, what to say, one more thing is there. That is one more part in the hydro power plant is there. That is known as surge tank. Okay, surge tank, somewhere images. This is surge tank. Okay, so these surge tanks, they are usually provided in high or medium head power plants. I hope you have understood what is meant by head. Okay, they are usually used in high or medium head power plants when we are using very long penstock. Um, okay, so whenever we are using very long penstock, their surge heads are used. Okay, not everywhere. So the length of this penstock is very large. So as I already shown you, in penstock, this is surge tank. So if the length of the penstock is very large, in such places, surge tanks are provided. So surge tank is nothing but a small reservoir or a tank which is open at the top. Okay, it is open at the top. You can see here top is open. Okay, and it is fitted between the reservoir and the powerhouse. So this is our reservoir. Okay, and this is our powerhouse where power is generated. Okay, so that is powerhouse. It is located in between these two. So the water level in the surge tank will rise or fall to reduce the pressure swing in the penstock. Okay. So purpose of the surge tank is now see purpose of surge tank is now water is stored here in this reservoir. So what is happening? The potential energy is gradually building up. Okay, so when the control gate is open, here gate will be there. When the control gate is open, with high pressure, this water. So this is a narrow path. It was earlier water was stored in a wider area. Now it has to pass through the narrow path. So when water starts to flow from the reservoir into the penstock, it has to pass through a very narrow path, and because of the high pressure exerted by the water, penstock may get damaged. So now to reduce the pressure, we are using the surge tank. So some of the water, before entering the penstock, the water can enter the surge tank so that the pressure developed inside the penstock is reduced. So in order to reduce the pressure inside the penstock, okay, so in order to reduce the pressure inside the penstock, surge tanks are used. Okay. Okay, now let us discuss about one more type of power plant, that is nuclear power plant. So, is there any issue with the session? Are you able to hear me? I don't know whether you are able to hear me or not. Okay, then I hope you are able to follow. Even if you are unable to follow, you can listen to this lecture later on. Okay, so I'm explain it. I'm not in a hurry um, to complete the lecture. So I'm trying to go as slowly as possible. So next type of power plant is nuclear power plant. So nuclear power plant, here what will happen in this power plant is, here heat energy is generated by a nuclear reaction. Okay, so by nuclear reaction, heat energy is generated. Okay, so that nuclear reaction is known as nuclear fission. Okay, that is known as nuclear fission. So this is nuclear fission. You can see an incident neutron is there. Okay, so here what will happen is fissile nucleus is formed. This fissile nucleus is splitting. Okay, so, and fissile product is when it splits, energy is released. Okay, due to fusion, I hope you know what is meant by fusion and fission. So due to fusion, here energy is released. That energy is when energy is released and further incident neutrons are further. Earlier it was one. Now when energy is released, few more neutrons are released. These neutrons will cause further chain reaction, and what will happen? More amount of energy is released. Okay, so I'm not uh, discussing in detail about nuclear fission. It's not my topic. Okay, so but you might, if you are attending this session, you might have already learned about fusion and fission. So here nuclear fission takes place. So nuclear fission of heavy elements such as here uranium or thorium is carried out in a special apparatus called nuclear reactor. So you can see in this image. Okay. So here you can see here this is reactor vessel it is mentioned. So this is our nuclear reactor. This is our nuclear reactor. So in the nuclear reactor, nuclear fission is taken place. The material that is used for nuclear fission is uranium or thorium. Okay. So due to nuclear fission, what will happen is large amount of heat energy is generated. Okay. Okay, large amount of heat energy is generated. That's it. Remaining parts you can see here turbine, here cooling elements are there, here generator is there. So all these components, remaining components are similar to the another power plants. Okay. So it is found that the fission of only 1 kg of uranium, if we are using only 1 kg of uranium to produce the heat energy, then it can produce here for 1 kg of uranium, it can produce an heat of around 4,500 tons uh, of the coal. Okay, so if you compare the heat energy produced by this, what is it, uranium with the coal, 1 kg of uranium, whatever amount of heat energy that this uranium can produce, it's equivalent to 4,500 tons of the heat energy produced by the coal. So, which is better when compared to uranium and coal? Uranium is far better to produce the heat energy. because 1 kg is able to produce the same heat as 4,500 tons of coal is producing. Okay, so this if we are using nuclear reactor for producing the electrical energy, so if we are using nuclear power plant to produce electrical energy, it considerably reduces the transportation cost of the fuel. So we need not, if you want to use coal as fuel, so it has to be transported from wherever it is available. It has to be dug from the ground, and it has to be transported to the power station. Okay. So, but nuclear power plants are built wherever fuel is available, wherever uranium is available. At that location itself, nuclear power plants are built. Whereas wherever coal is available, there power stations are not built. So, power stations are built at some location. If coal is to be used as fuel, then it has to be transported. So, when compared to coal, that is one of the advantage of nuclear power plant. Okay. There are large deposits of nuclear fuels available all over the world. Hence, nuclear power plants can ensure continued supply of electrical energy for thousands of years. Okay, so about 10% of the total electricity of the world is generated by the nuclear power plant. So you can see some image here. So I have few more images. So see here, this is our nuclear reactor. Okay. And this is known as, you can see some this. Okay, these are the fuel rod means that is what to say, uranium or thorium. Okay, so uranium or thorium, this you can see this, I'm unable to mention the uh, color, some grayish color rods. You can see they are the fuel rods, and in between the fuel rods, control rods are provided to remove excess electrons. Okay, to remove the excess electrons, control rods are provided. Around the fuel rods, a moderator is placed. You can see brown color lining. You can see moderator. You can see brown color lining provided around this fuel rod. Just carefully observe the image. If you want, you can draw this image. Okay. So around the fuel rod, moderator is provided. Okay. So one more component that is available here is pressurizer to control the pressure, coolant pump to remove the excess heat. Coolant pumps are used. Okay. So this is a heat exchanger. This is known as heat exchanger. Here, heat is exchanged. So here, water is allowed. You can see to a cooling tower, it is mentioned cool water is allowed to flow through this, and it is taking away the heat and it is returning. So here, water gets heated up. Okay, in this chamber, heat exchanger. In the heat exchanger, water is getting heated up. It is converting into steam. That steam is sent to the steam turbine. So here, what is happening? Turbine, similar to your hydropower plant. In the turbine, what is happening? The turbine blades are rotating. When the turbine blades rotate, shaft will rotate. Hence, the generator, okay, rotor will rotate. If generator rotor rotates, or rotor windings will rotate, these rotor windings will cut the magnetic field and EMF is induced. I have one more image. See here. Uh, Fuel rods, nuclear reactor vessel, nuclear reactor, control rods, and this is our heat exchanger. So water is entering here. That water is heated, and steam is water is converted into steam. That steam is sent into the turbine, and shaft will rotate because of this steam. Okay. So this steam is again condensed into water in this condenser. Okay. And this hot water, the steam is converted into water here in the condenser. But the even though steam converts into water, that water will be hot. So that hot water is sent to chimney. Okay. So this is a chimney cooling tower. We can call it as cooling tower. So here water is cooled, and that cool water is once again returned back to this heat exchanger. So see here, this is our cooling tower. So these are the cooling towers. This is our nuclear power plant. So see here, these are the cooling towers. These are the cooling towers, and these cooling towers, so you can see here some fumes. These are not the fumes. These are the water vapors. These are the water vapors. Water vapors. These are the water vapors. My cursor, it won't listen to me. So these are the, I will write water vapors. Okay, water vapors coming out of what? Cooling towers. So actually, I once went into the cooling tower, but not for the nuclear power plant. I once went to the thermal power station. There, I went into the cooling tower. So they are very huge in size. Okay. So this image you can see the control rods. This is our reactor. This is our heat exchanger, or you can give one more name is given, steam generator. So here in the heat exchanger, what will happen? When cool water enters here, water is converting into steam. That steam is sent to the turbine. This is our turbine. When this steam turbine shaft rotates, generator will rotate, and the steam is sent to the condenser. In the condenser, the steam is converted into water, and that water is sent to the cooling tower. When water is sent to the cooling tower, hot water is sent to the cooling tower. In the cooling tower, water gets cooled, okay, and this cool water is once again sent back to this heat exchanger, okay. So let us discuss about the basic components of this nuclear power plant. One of the component of nuclear power plant is the nuclear reactor. This image is best to draw. So if you want, you can draw this image. Let me check whether I am in the class or not. Okay, I hope I am in the class. Okay, then let us see discuss about the components of the nuclear power plant. So the nuclear reactor. This is the nuclear reactor. In this image, it has mentioned only reactor, but it is usually known as nuclear reactor. So nuclear reactor is a special apparatus which is used to perform nuclear fission. So here, nuclear fission is radioactive. So the reactor is covered by a protective shield. So this reactor, it is covered by a protective shield. Why? Because nuclear fission is radioactive. So we should not be exposed to this radioactive materials. So that's why it is always um, provided with proper enclosure. Okay. So so the splitting up of the nuclei of heavy atoms is called as nuclear fission, that you people already know, during which huge amount of energy is released. So this nuclear fission is done by bombarding slow moving neutrons in the nuclei of heavy elements. Heavy element means uranium. So as the nuclei breaks up, okay, what will happen? It releases energy as well as more neutrons, which further cause fission of neighboring atoms. That's what I have shown you earlier. It's okay. See here, as the nuclei breaks up, what will happen is it will release energy as well as more neutrons, which further cause fission of neighboring atoms. Hence, it will cause a chain reaction, which must be controlled. Otherwise, it may result into explosion. Okay. So that way we are using what? Control rods. Okay, so control rods are used for absorbing the excess electrons, otherwise it will explode the whole chamber. Okay, so nuclear reactor consists of what? Fuel rods. Okay, nuclear reactor consists of fuel rods, moderator, and control rods. Okay, these are the three things that are available in the nuclear reactor. So nuclear reactor is consisting of what? Moderator, fuel rods and control rods. So fuel rods contain small round fuel pellets, uranium pellets. So these are the fuel rods, isn't it? So they are the small, round means cylindrical, not round exactly. They are not round, they are cylindrical. Okay, next, control rods. Control rods are made up of cadmium, which absorbs the neutrons. Okay, so they are inserted in the reactor and can be moved in or out to control the reaction. Okay, so these control rods, if you carefully observe here in this image, there are three control rods. This one, and this one. All are not in same shape or same position, isn't it? These two are in same shape and position. These two are in same position, but this rod is not in same position. Okay, so these control rods, they can be moved inward as well as outward to the nuclear reactor. Okay, so they are inserted into the reactor and can be moved in or out to control what? Control the nuclear reaction. Okay, so this one more thing here. Fuel rod is uranium or thorium. Control rods are what? They are made up of cadmium. One more thing inside the nuclear reactor is what? Moderator. So the moderator can be a graphite rod or coolant itself. Okay, coolant means some cooling agent you can use. So here, just to be more specific, let us assume that the moderators are made up of graphite rods. So moderators slow down the neutrons because they before they bombard on the fuel rods. Okay, so what do this moderator do to reduce the um, speed of the neutrons of the uranium? This moderator is. So moderator slow down the speed. Control will absorb the excess neutrons. Okay, that's it. So there are two types of nuclear reactors: pressurized water reactor and boiling water reactor. Two types of nuclear reactors are available. One is pressurized water reactor. Another one is, I'm just checking if there are images that are available here with me. I didn't collect any image. Okay, it's okay. Pressurized water reactor, or another one is boiling water reactor. So let us discuss about the pressurized water reactor. This type of reactor uses regular water as coolant. Okay. So the coolant that is used here, cooling pump, you can say, the coolant that is used here is water. The coolant is kept at very high pressure so that it does not boil. Okay, so here pressurizer is kept here. So coolant is kept at high pressure so that it does not boil. The heated water is transferred through heat exchanger. I have already explained about it. The heated water is transferred through the heat exchanger where water from the secondary coolant loop is converted into steam. Okay, so it is converted into steam. Okay. Okay, so most commonly the pressurized water reactors are used. Now let us see another type of nuclear reactor, that is boiling water reactor. In this type of reactor, only one coolant loop is present. Okay, so only one coolant loop will be present in the boiling water reactor. The water is allowed to boil in the reactor itself. Okay, so here in this image, water is not boiling in the reactor, but the water is allowed to boil inside the reactor itself. Okay, so the steam is generated as it heads out of the reactor and then flows through the steam turbine. Okay, so this is what happens in boiling water reactor. So one of the major disadvantage of this is that coolant water comes in direct contact with the fuel rods as well as the turbine. So there is the possibility that radioactive material could be placed in the on the turbine. So as water is directly entering into the reactor, okay, if water enters directly into this reactor, what will happen is there are chances that the radioactive material enters the steam turbine. Okay, so which is dangerous. Okay. So heat exchanger, you can see this heat exchanger. It is not available in your boiling water reactors. That's not available. Okay. Next, let us discuss about the steam turbine. Where is my cursor? This is it. Let me erase all inks. Let us discuss about the steam turbine. So steam turbine, here what will happen? The generated steam is passed through the steam turbine, which runs due to the pressure of the steam. Okay. So as the steam is passed through the turbine blades, the pressure of the steam gradually decreases and it expands in volume. The steam turbine is coupled with the alternator, that is generator, and it rotates the shaft of the generator. Okay. So now let us discuss about this generator. Let us discuss about the generator. AC generator is also known as alternator. So the steam turbine rotates. So what will happen? Shaft of the steam turbine rotates. As shaft rotates, automatically the generator shaft will also rotate, and the rotor will rotate. Okay, and as rotor rotates, rotor windings will cut the magnetic field of the stator winding magnetic field, and EMF is induced in stator windings. Okay, one more part here, it is condenser. Okay, so the steam coming out of the turbine after it has done its work is then converted back into what? Water. Steam is converted into water in the condenser. The steam is cooled by passing it through the uh, cool water loop. Okay, so here cool water is continuously entering from the cooling tower. Cool water is continuously entering. Hot water is going out. Cool water is entering here. So definitely what will happen when hot water enters? So when steam enters, from the steam turbine, steam will enter this condenser, and here cool water is entering here. So steam is converted into water, and this water that is entering here is getting heated up. The hot water is again sent back to the cooling tower. Okay, so the heavy elements such as uranium or thorium, which is used here, it is subjected to nuclear fission in nuclear reactor. So due to fission, what is happening in the nuclear reactor? Large amount of heat energy is produced, which is transferred to the reactor coolant. Okay, so this coolant may be water, gas, or it can be a liquid. Okay, so the coolant that is used here, it can be that is heat exchanger, you can say. So here, coolant that is used here, it can be either water, gas, or liquid. The heated coolant is made to flow through the heat exchanger, where water is converted into high temperature steam. So the generated steam is then allowed to drive the steam turbine. Okay, so when steam turbine runs, automatically generator will run, and electrical energy is generated. Voltage is generated or EMF is produced, means electrical energy is generated. So this is how nuclear power plant works. So one more power plant is there, that is solar power plant. I think this is the last one. This is the last electrical energy generating power plant. I will discuss this and I will conclude this session. Solar power plant. So let us discuss about the solar power plant. So you can call this solar power plant as a photovoltaic power plant or PV power plant. Okay, PV power plant or photovoltaic power plant. You can call the solar power plant. You can see here some solar panel. Cursor is there. So this is solar panel. This is sun. So the heat produced by the sun is absorbed by the solar panels. That heat energy is converted into electrical energy, and that is given to the load. That's what happens. In simple words, I have explained about the solar power plant. So here, large scale PV plants are designed to produce bulk amount of electrical energy using the solar radiation. So the solar power plant uses solar energy to produce the electrical energy here. Okay. So the solar energy, it can be directly used to produce the electrical energy using the PV panels. Okay. So in this type of plant, the radiation energy of the solar first converted into heat energy, that is thermal energy, and this heat is used to drive the generator. Okay. So this method is difficult and not efficient to produce the electrical energy in a large scale. Hence, to produce electrical energy in large scale, solar PV panels are used. Okay. So conventional method, directly simply using one panel is not sufficient. We need large number of PV panels. That's it. Okay. So large number of PV panels are required to generate the electrical energy. So large number of PV panels you can see here. So some many panels are there, solar panels. They are fixed there to convert heat energy into electrical energy. So let us see how this heat energy of the sun is converted by using this PV panels. Okay, so let us see. So here the solar cells. Okay, so or the PV cells. I have one more image. I will put that. So this is a PV cell. This is a photovoltaic cell. Okay, so usually here silicon is used as solar cell or PV cell. Silicon here you can see in this image, if you carefully observe, where is my cursor here? This is N layer, depletion layer, energy band. Okay, P layer of this silicon material, silicon cell. So I will erase all it. So see, this is our silicon cell. So the lowermost, this is P layer, uppermost is N layer, in between depletion layer. So my cursor is sensitive. In between, what is the depletion layer, N layer and P layer. So this is, we here silicon material is used, silicon cell is used as solar cell. Okay, so what is, we can use them, but usually silicon is used. Electron hole pairs are created in this solar cell actually. Okay, if you observe carefully, it's an energy band. You can see N layer, P layer, depletion layer means. So you can easily say that electron hole pairs can be created using the solar cells. The PV material having the have the property to absorb photons from the sunlight. Okay, so this PV material has the property to absorb what? Photons of the sunlight. So the valency band electrons of the semiconductor material are of low energy and the electrons of conduction band are at high energy. Okay, so valence electrons will have low energy. Valency band electrons will have low energy and conduction band will have high energy level here. Okay, I have one more image. You can see this image inside the photovoltaic cell. Okay, inside the free photovoltaic cell. So here, um, above the N layer, glass is provided. Glass is provided. This is P layer. Inside this dotted line, if you carefully observe, that is the junction. Okay. So here, you can see if you observe this diagram, these yellow dots, if you carefully observe, they are the free electrons. They are jumping. Okay. These electrons are jumping into the conduction band from the valency band. Okay. So the valence, what to say, this valence band electrons of semiconductor material are at low energy and the electrons of conduction band are at high energy level. Therefore, that this difference between the energy levels is known as band gap energy. Difference in the energy levels of these two, valency band and conduction band, is known as band gap energy, and you can give some notation to it, some band gap energy, E suffix G. Okay, E suffix G. Okay, my cursor, I have to operate it carefully. EG. Okay, so that is the band gap energy. Do I have any image? No, I don't have much images. Okay, when the sunlight falls on the solar cells, okay, so the sunlight. So when sunlight falls on the solar cell, the difference between the photon energy and the band energy is absorbed by the cell. Okay, so difference between the photon energy. Let us assume sunlight photon energy is E, and this E will never be equal to Eg. So there will be a difference. Okay, because of this energy, the photon energy and energy band gap energy, what will happen is heat energy is absorbed by these solar panels and it will excite some electrons to jump across the band gap. Okay, so this will cause the electrons to jump across the band gap and these electrons will move from the valency band to the conduction band and create holes in the valency band. Okay. Therefore, if the potential difference exists between the cell, then the electrons of the conduction band and the holes of the valency band will make the flow of current in the circuit. So because of this, what will happen? Current start to flow. You can see these arrow marks. Okay. This will cause the current to flow. Okay. So once again, I will repeat. The valency band electrons of the semiconductor material are at lower energy level and the electrons of the conduction band are at higher energy level. So valency band electrons are at lower energy and conduction band electrons are at higher energy. So this difference will cause energy band gap. So that energy band gap you can give some notation that as Eg and the sunlight which falls on the solar cells. Okay, so it will have certain energy that is known as photon energy E. Okay, this E and Eg will never be equal. There will be a difference in these two energies. So because of this energy, okay, what will happen is the light energy, because of this difference, light energy is absorbed by or the photon energy from the sun is absorbed by these cells. It will excite some electrons to jump across the energy band gap. Okay, and these electrons will move from valency band to the conduction band and they will create holes in the valency band. Okay, and if this energy difference or voltage difference exists within the cell, then the electron from the conduction band and holes of the valency band will make the current to flow. So the energy of these photons, which is directly, it will be always directly proportional to the frequency of the radiation that is coming from the sun. Okay, so let us discuss about the photovoltaic system. So this is a solar PV model. Do we have any images? Let us see. So, so these solar PV models, they can generate the electrical energy only when sun is shining on it. Okay, when sun is there, and if sun rays are falling on it. If clouds are there in between sun and the PV panel, then electrical energy cannot be generated. Okay, so if there are, suppose there are, my cursor, if there are clouds, so let us assume this is a cloud which is not allowing. This is a cloud which is not allowing sun rays to fall on this panel. Then this solar panel cannot generate the electrical energy. So for the electrical energy to be generated, rays should fall on the PV panel. So there is no storage of power generated, hence batteries are not there. Okay. So batteries are required whenever we want to store the electrical energy. So here, depending on type of the load, okay. So here load is what? House is the load. Depending on type of the load, so whether the load requires DC energy or AC energy, depending on that, we can use the inverter or we may not use the inverter. So here the electrical energy that is generated is DC. Okay, in the photovoltaic panels. The energy generated is DC. Sorry, DC. I have written DE. DC energy is direct current. Okay, DC is generated If I require in the houses, if I require AC, of course we use AC, alternating quantity. So since we require alternating quantity energy, but generation is DC, therefore we need an inverter. Okay, so inverter may or may not be used depending on the load requirement is what is it? Depending on the load requirement is whether it is DC requirement or AC requirement. Okay, now this solar PV system, it can be off-grid system or grid connected system. Okay, I will drink water and come 1 second. Okay, so let us discuss about the off-grid system. So, off-grid system is used in the locations where power from the grid is not available, okay, or not reliable. Okay, so you can't rely on the grid system wherever the locations, wherever we can't rely on the grid system or the power from the grid is not available. In such areas, we go for off-grid system. So off-grid solar power is not connected to the electrical grid. Electrical grid means if you see here, solar in this image, cursor here. So these are the solar panels. Okay. So whatever energy that is generated in the solar panels by the solar panels, it is stored in the batteries and it is through the inverter, it is given to the load. Okay. And the optional generator is connected here. Optional generator means diesel generator. We already know in our wherever we work, in the workplaces we know if power is discontinued, so diesel generators are used. That's just the optional one. That is also connected to the inverter. Okay. So if it is a grid system, you can see from the power plant, it can be hydel, tidal, thermal. Okay, what are maybe the power plant? Okay, so from the power plant, electrical energy is given to the load. This is our load. This is a house, and along with that, you can see solar panels are also there, located above the house. Means here the electrical energy that is generated with the solar panels can be utilized by this house, as well as the energy that is supplied from the power plant can also be utilized by this house. Okay. So these solar power plants, they are tied up with the grid here. Okay. So they are connected to this grid. Okay. The solar panels are connected to the grid here, so that excess required power can be accessed through the grid. Means if the energy generated by the solar panels is not sufficient enough to fulfill the demand of this load, then remaining energy can be utilized from the energy that has been supplied by the power plant. Okay, so they may be used as a backup plan. Okay, if the solar panels are generating excess power, that can be stored in the batteries. Here batteries are not shown here in this image. We can even use batteries. Okay, so that is grid connected system. Okay, so let us see various components of the solar power plant. So one of the component, as I've already discussed, photovoltaic, that is PV panel. Next, inverter, energy storage device, charge controller, system balancing component. Okay, so let us start with the photovoltaic panel. So or PV panel. I have some images here. So photovoltaic panel or PV panel is most important component of solar power system. Okay, it is made up of small solar cells. Okay, so this PV panel is made up of what? Small solar cells. So you see, this is a cell. This is a photovoltaic cell. It is made up of small solar cells. So this is a device that is used to convert solar photon energy into what? Electrical energy. Okay. So PV panel or the photovoltaic cell is the one which converts solar photon energy into electrical energy. Okay. So here the material that is used for this cell is what? Silicon, which is a semiconductor material. Okay, so silicon is the semiconductor material which is used as solar cell. So photovoltaic cell is nothing but silicon cell. Okay, so the typical rating of the silicon solar cell is will be around 0.5 volts and 6 amperes, which is equivalent to 3 watt power. Okay, so its rating of this cell will be around 0.5 volts, and in amperes 6 amperes, and power is 3 watts. This is the rating of this photovoltaic cell. Okay, so the number of cells, they are either connected in series or parallel. So you can see here solar, these are the solar panels, not cells. Okay, so these cells, they can be connected, analyzing on it, connected in series or parallel to make a module. So you can see here, this is a module, this is a cell. So you can see number of cells. They are connected in series or parallel to form what? A module. So cells are connected in series or parallel to form a module. Okay, to form a module. The number of module forms a solar panel. Okay, so now this is one panel. Silicon cells. Okay, they are connected in series or parallel connection to form a module. So this one module is this is one module. So these modules are further, number of modules are connected together to form a panel. So see here three modules are there, isn't it? In this image, three modules are there. So modules are connected together to form a solar panel. So panels are again connected together to form an array. Okay. So depending on the capacity of the power plant, number of plates are mounted and a group of panels are known as photovoltaic array. Okay. So you can even connect them, these panels, you can connect them either in series connection or in parallel connection. These panels can be connected either in series or parallel. Okay, even cells are connected in series or parallel to form a module, and these panels can be connected in series or parallel to form uh, depending on the requirement. Okay, so depending on the energy requirement, you can either connect in series or parallel. So you can see this is one panel whose rating is 12 volts 8 amperes. This is also 12 volt 8 ampere, 12 volt 8 ampere. So total voltage is 36 volts 8 amperes and power is 288 watts. Whereas these panels, these are series connected panels. These panels are connected in series. If we are connecting these panels in parallel of same rating, so total voltage will be 12 volts, current 24 amperes and 288 watts power. So these are the ratings of these solar panels. So now let us discuss about the inverter. Let us discuss about the inverter. Okay, so inverter is required whenever we want to convert DC into AC. As I've already told you, so you can see in this image PV model. As I already told you, whenever we want to convert DC to AC, to convert DC to AC, I thought everything is going well, but see, whenever you want to convert AC to DC, you need an inverter. Okay, so from the panel, what is the electrical energy that is produced? That is DC electrical energy is produced. So and most of the loads, okay, most of the loads are what? What type of loads are there? Cursor, where is cursor? Yeah, most of the loads are AC loads. So we definitely need an inverter to convert DC to AC. Okay, so inverter is used to convert DC power to AC power. Okay, so in large scale grid connector power plants, inverter is connected with a special protective devices. Okay, and a transformer is also connected with the inverter to ensure the output voltage and frequency as per the standard supply. Okay, so you can even connect a transformer to the um, inverter. Okay, so next, energy storage devices, that is battery. That is energy storage means battery bank. You can see here battery bank. So energy storage device. So batteries are used to store electrical energy generated by the solar power plant. So the storage components are the most important component in the power plant to meet the demand of the various types of loads. Okay, so if the electrical energy is not utilized by the load and these PV panels are continuously generating the energy, that energy has to be stored somewhere. So that energy is stored in what? In the batteries. Okay, so this now when energy is stored in these batteries, and if suppose during the night time we know that sunlight is not available during the night time, so whatever energy that is stored in the batteries, that can be given to the loads. Okay, so the capacity of the batteries is usually measured in ampere hour rating. So if batteries have, for example, if a battery is having 100 ampere hour battery okay, so if the battery is having 100 ampere hour capacity, so and it can supply 1 ampere current for 100 hours or 100 amperes current for 1 hour. Okay, so depending on the requirement, its rating or capacity can be changed. So for a longer life of battery, okay, the battery should not be completely discharged. So I don't know how many of you know the mobiles that we use. Okay, so before it is completely turned off, because if the charge is over, if the charging in the mobile is over, before it is completely dead, we must charge it once again. So what I do is usually if I see the mobile charging is 20% or less than 20%, immediately I charge my mobile. Okay, so what is the need to charge the mobile even though at least 20% charging is available? What is the need to once again charge the mobile? The reason is the life of the battery will increase. So in order to increase the life of the battery, here also it is not fully discharged. So and in case if battery is fully discharged, never keep fully discharged battery for longer time. So if the battery is fully discharged, it should not be used for longer time. The capacity of the battery is affected by the temperature also. So there is a reduction of 0.6% of the capacity for every degree Celsius rise in the temperature more than 25 degrees Celsius. Okay, so there are two types of batteries used in the solar panels, lead acid battery and nickel cadmium batteries. Okay, so one more component in this solar power plants, one more component is charge controller. Okay, so charge controller is used to control the charging and discharging of the batteries. So here batteries are charged and they are later if required they are discharged. Okay, so To control the charging and the discharging of the batteries, charge controllers are used. Okay, so the one of the main purpose of this charge controllers is, okay, one of the main purpose of charge controllers is they make sure that the batteries are not overly charged. So okay, so batteries have certain capacity, so beyond their capacity they should not be overly charged. Okay, why? Because if the battery is overly charged, that may lead to the corrosion and reduce late growth. Okay, so and in this worst condition, it may even damage the electrolyte of the battery if it is overly charged. Okay, so we can give another name to the charge controller. Another name to the charge controller is solar battery charger. Okay, so charge controller is also known as solar battery charger. Okay, so there are many technologies that are used to make this charge controllers. The most popular technique in the is the MPPT charge controller, that is maximum power point tracking method that is used in the PV system. Okay. Next, next is voltage regulator. The voltage regulator is not. Let me check if I have the image of the voltage regulator. Yeah, one more power plant is also there. I didn't notice. Okay, the image of this voltage regulator is not shown here, but one more component is the voltage regulator. The output of the solar panels will depend on the sunlight that we already know. I'm checking if I have the image of the voltage regulator. So the output of the solar panels, it will definitely depend on the how much sunlight is falling on the solar panels. Uh, So we already know that sun rays coming out of the sun, they are not constant throughout the day. Okay. So sunlight is not available constantly. So it is continuously varying throughout the day. Okay. So similarly, as the sun rays are continuously varying, sun rays that are falling on the panel, okay, sun rays that are falling on this panel are continuously varying throughout the day. Definitely, the electrical energy generated by these solar panels will also vary continuously. Okay, so definitely load current. Okay, load current, the current that is given to the load is not constant here. Okay, the current that is given to the load is not constant. That is also continuously varying. So we need voltage regulators. So we need what? We need some voltage regulators. My cursor, it won't listen to me. Okay, voltage regulators. I don't like it. Okay, we need voltage regulators in order to regulate the voltage that is given to the load. Why? Because the current is fluctuating. The energy, the electrical energy that is generated with the solar panels is continuously fluctuating. So voltage regulators are used to maintain the fluctuation within acceptable range. Okay. Okay. So here in this solar power system, the type of solar power system in this type of also solar power, it can even be concentrated solar power. Okay, solar power can be concentrated solar power. In this type of, if the solar power system that is used it is concentrated, then sun rays are concentrated on a small area. Okay, so I think I have the image. This is it. Okay, so we can use a concentrated solar power system. So where the solar power is allowed, sun rays are allowed to concentrate on a small area by placing mirrors or lenses over a large scale. So you can see here, mirrors are placed here over a large scale so that sun rays can be concentrated on these mirrors. Hence, huge amount of heat is generated at the focused area. Okay, because of this, what will happen is huge amount of energy is generated at the focused area. This heat can be used to heat up the working fluid, which can further dry the steam turbine. We can do that. There are different types of technologies that are based on the concentrated solar power to produce electricity. Some of them are parabolic throw or Stirling dish or solar power towers. Okay. So here solar power we are using. I'm not showing the other two. I'm showing only one type of concentrated solar power energy system, that is a solar power tower. So here you can see solar power tower. So light rays are allowed to fall on the mirrors, where they are being concentrated at one point on the mirror, and these solar rays which are falling on the mirror, they are again reflected back to a single mirror. Okay, so all the rays are concentrated at one point. Because of and when they are falling on one point, the enormous amount of heat is produced, and that heat energy is utilized here to run the steam turbine. I think here water will be there. That water is heated up, and it is converted into steam. That steam is will flow through the steam turbine, and the steam turbine will rotate, and hence the generator will also rotate. Okay. Okay, this is about the concentrated type of solar power system. Here, the basic components of home power system, that is this home power system. This is a solar power system that is used for homes. Okay, so the basic components of this home solar power system are solar alternative photovoltaic systems. Okay, which are not complex. So this is it. So the solar alternative photovoltaic cells. Okay, so these panels will simply collect the sun rays, and it will convert that heat energy that is produced by the sun rays into electrical energy. Okay, so here DC signals that are produced by these panels, DC energy that is produced is converted into AC by using the inverters. If the load demand is not there, then the energy will be stored in these batteries. Okay, when sunlight is not there, then whatever energy, electrical energy stored in the battery, that is fed back to the home. Okay. Okay. So this is about the solar power system. Let us discuss about the wind power plant. Next topic is this is the last one. I thought forgot about the wind and I was discussing. I thought solar was the last one, but one more topic is there. Wind power plant. I will discuss about the wind power plant and I will conclude. Uh, if you want, you can draw the diagram. I will give you a minute. let us discuss about this wind power plant. So, wind is one of the renewable energy source, and it can efficiently convert wind energy into electrical energy if we are using a windmill. Okay, so this is known as windmill. Where is my cursor? Yeah, this is known as windmill. It will have blades. Okay, so when these blades rotate, when wind blows, these blades will rotate, and this will windmill will convert the what we say wind energy into electrical energy. How it converts, let us see. So you can even call it as windmill, or you can even call it as wind turbine. Okay, let me see, is there anything written here? Some in this image, nothing is mentioned. Okay, so you can even call it as wind turbine. Okay, so the wind turbine will have blades. These are, you can see in this image, three blades are there. So these blades, you can even call them as rotors, or you can even call them as aeroplane wings or helicopter rotor blades. Okay, here this wind turbine, it utilizes the aerodynamic force from the rotor blades to generate the electricity. Okay, so this what this wind turbine will do is it will harness the kinetic energy of the moving air when air is blown. So usually these windmills, wind power plants are located, or windmills are located in the areas where heavy wind blows. Okay, so I have some images, I will show you. Yeah, so see here, in the areas where wind blows, in such areas these wind turbines are located. Okay, so you can see in these two images the wind turbines. So they are usually located in the areas where heavy wind blows. So what these wind turbines will do is they will harness the kinetic energy of the moving air, and they will convert it. The wind energy is converted into rotating energy of these blades. Okay, so the wind energy, because of the wind, the blades will start to rotate. So these blades, they will start to rotate. Okay, so this rotating energy is transferred to the generator via a shaft producing electrical energy. So where is our image? First one. Yeah. So this is cursor. So where is my generator? Yeah, generator will be here itself in the notch. Okay, so here itself above the tower. This is the tower, isn't it? This is the foot of the tower. Okay, so at the head of the tower there will be a nacelle in which generator is there, gearbox is there, controller as well as rotor shaft. Everything will be there here itself. So here itself electrical energy. Okay, behind the blades itself electrical energy is generated. The generated energy is stored in the batteries. So the generated energy is DC. So we need an inverter to convert it into AC. And that energy is given to the loads. It can even be industries, or it can even given to the grid that is connected to some other power plant. Okay. Okay, so we can even connect these wind power plants along with the some other power plants such as solar power plants. We can combine the energy of these two power plants to, when the power plants are connected together, we can call together, they are called as hybrid plants. Okay, so if one source is unable to generate the energy, meanwhile other source can be utilized to generate the energy, and that energy can be given to the loads. So with the minimal environmental impact compared to the fossil fuel burning, wind power offers clean and valuable investment of the electrical energy. So these turbines which are available, turbines means, where is my cursor? Yeah. So these blades that are available here, they will simply collect the wind energy, and they will, because of the wind, they will start to blow. Blow means they will start to rotate, and when these rotor blades are rotating, the shaft that is connected at the center, it will rotate. When the shaft rotates, shaft of the generator which is placed inside here, in the inside the nacelle, it will start to rotate. And when the rotor of the generator rotates, and when the rotor windings cut the stator magnetic field, EMF is induced. Okay, that energy is used by the domestic or commercial purpose. Okay, so these blades or these wind turbines, they are designed in such a way that the height and length of the blades are maintained at same ratio. Okay, the height and length of these blades are maintained at same ratio. Okay, among all power plants, wind power plant is the one of the major plant with more than 20 years of lifespan. So lifespan of the wind power plant will be very large. It will be around 20 years. Okay, but it requires some maintenance every 6 months. Okay, once in 6 months, maintenance is required by these wind power plants. So overall efficiency of these wind power plants will be around 20 to 40%. Okay, and this turbine does not operate at wind speed above 50 uh, mph with the use of the controllers. The rotor shaft of these turbines, okay, so it can be low speed or high speed rotor that is connected. Means rotor shaft means generator rotor shaft. It can be high speed or low speed, and it is interlinked with the gearbox, which converts the speed from 30 to 60 revolutions per minute into 1000 to 1800 revolutions per minute. So gearbox is connected, it can convert that whatever speed with which the blades are rotating into a higher speed. So as the gearbox consists of gears, it transmits mechanical energy from these rotors to the generator. These speeds are most suitable to the generator for generating the electrical energy. Okay, so I have one more image. So I think I didn't see that. This one. So you can draw this. This is best. Okay, you can see here. You can see two blades. We can call them rotor blades. Okay, so this is the gearbox. This is the generator. This whole structure, this one, is known as nacelle. Okay, so this is the tower. At the bottom, there is a transformer. This is the concrete foundation. And the height of this nacelle with respect to the ground is known as hub height. Okay, so when the rotor of this turbine rotates, if you want, you can draw this image. So when the rotor of the turbine rotates, it drives the generator through a setup gearbox and causing the generator to produce electrical energy. The windmills are available at sizes from 100 kilowatts to 36 megawatts. Okay, mainly in offshore areas. Okay, so there are two types of wind power plants. So what are those two types? If you are drawing, you can draw it later on after this session is over. I will conclude within few minutes. Okay, so I want to show some images. So there are two types of wind power plants, depending on the how the blade is there mm, on the nacelle, the blades that are fixed at the nacelle. There are two types. One is horizontal axis wind turbine, other one is vertical axis wind turbine. So horizontal axis wind turbine, you can even call it as HAWT, and vertical axis wind turbine, you can call it as VAWT. So the in horizontal axis, the rotating blades of the wind turbine is parallel with the ground. Okay, so these blades are what? Horizontal. In horizontal axis wind turbine, the blades will be parallel to the ground. Okay, and this horizontal axis wind turbine, it can produce more electricity compared to the vertical axis wind turbine. Okay, for a particular amount of wind. Okay, so when compared to, so in vertical axis wind turbine, the blades will be perpendicular to the ground. Okay, and the electrical energy produced by this vertical axis wind turbine will be less when compared to the horizontal axis wind turbine. So this see here, so this is horizontal axis and these are the vertical axis wind turbines. Okay, so simply when wind blows, what will happen? I'll briefly discuss. When wind blows, these blades will rotate. Okay, these blades will rotate. When these blades rotate, okay, so there is a mechanical brake also provided here to control the speed and gearbox to change the speed. Okay, so it can convert the speed from, as I've already told you, it can convert the speed of around 30 to 60 revolutions per minute into 1000 to 1800 revolutions per minute, and that speed is given to the generator. Okay, so when generator and when the rotor rotates at that speed, generator will generate the electrical energy. That electrical energy is given to the load sectors. Okay, that is how wind power plant operates. Okay, the session is over. The session is over. I will send, if you want, you can draw this. Meanwhile, I will send you a link to get the attendance.
Huh.
Fill the Google form for attendance. All of you fill the Google form for attendance. After filling the Google form, you can mention count. Just type C in the chat box and you can leave.